Hey guys, this is Coach Lowe, and we are going to talk about circles today and their measures and maybe some arcs and some chords, all kinds of good stuff. So let's go ahead and get started. In your book, this will be 10.3 and 10.4. All right, so let's go. So first of all, let's get some theorems out of the way. So this is 10.3 arcs and chords. And when I say theorems out of the way, I mean let's get some theorems so we can understand what we're doing, right? All right, so let's say that we have a circle, or you could have two circles that are congruent to each other. Minor arcs are the same length. So these arcs right here, let's go A, B, C, D. So AB, arc AB is congruent to arc DC if and only if their chords are congruent. So that works both directions, if and only if. Remember, we can abbreviate IFF. So in the same circle or congruent circles, two minor arcs are congruent if and only if corresponding chords are congruent. All right, so in our case, arc AB is congruent to arc DC if and only if AB, segment AB, is congruent to segment DC. Now remember, minor arcs mean that they measure less than 180 degrees. And these do, 180 would be a semicircle. So let's try a little example. I'm going to do two congruent circles since we've already kind of looked at a circle here. Let's get two congruent ones and we'll check this idea out. All right, so here are two circles. They are congruent to each other. And so I have circle A and circle B. And chord RS is 6x minus 5. And chord UT is 3x plus 10. And arc RS is congruent to arc UT, so they're the same length. All right, so knowing that those two arcs are congruent to each other, I know that these two chords, RS and UT, are exactly the same length, which means if I'm trying to solve for X or find the length of the chord, and let's do both, I will set these guys equal to each other. Since they're congruent, that means their measures are equal. So let's set those equal to each other and solve. So subtracting 3x from both sides, and then adding 5 to both sides, x is 5, and then taking 5 and plugging it into either one of these two. So let's plug it into UT. 3 times 5 plus 10 is 15 plus 10, or 25. Now a quick check to make sure I get 25 for this one. 6 times 5 is 30, minus 5 is 25. Should get the same number for both of those. So when I solve for x, I get x equals 5. The length of chord RS is 25. The length of chord the length of chord UT is also 25. So we know the lengths of those chords. All right. They could also give us arc measure, and we could solve for that. So they could give us chord length, or we could be solving for the arc measure. All right. Moving on. Next theorem. This is 10.3. Not section 10.3, but theorem 10.3. All right, so if we have a diameter or a radius, so I'll start to draw the chord first. If we have a diameter or a radius, and it is perpendicular to a chord, the diameter will bisect that chord. All right, so if these guys are perpendicular, the diameter is going to bisect that chord. It also bisects the arc. All right, so I have a diameter perpendicular to a chord. It will bisect that arc. Now this is also true if I have a radius. So let's say that this guy is shorter. It still bisects the chord and the arc. So cuts it into two equal pieces. All right, so that looks like this. Let's go ahead and do, how about A, B, C, D, call that E. All right, so AB is perpendicular to CD. Then we know that CE is congruent to ED. And also CB, arc CB, is congruent to arc BD. All right. Now, a couple of things to think about here, and because I could give you all kinds of different things, but notice if I connect this radius right here, I know the length of this radius, or I could know it, and I know that these two guys are equal. So I have a right triangle here. I would be able to find this length, which means I could also find this one if they give me the measure of the radius. So lots of different things they could ask you here. All right, let's try one of those while we're here. All right, so go ahead and draw a circle. And let's go ahead and label this A. We'll get this radius going. Radius AB. And then we have chord CD coming across. And this is E. And AB is 14. The radius is 14, which means AB is 14. And you're also given that CD is 22. All right. I didn't quite get that in the middle, did I? All right, so that means these guys are, this is perpendicular, by the way. A, B, and C, D are perpendicular because I have a radius and a chord here, perpendicular to each other. These arcs are congruent. All right, we want to find the measure of EB. Find the measure of EB. Okay, so that's this guy right here. All right, so let's think about how we're going to have to do that. Well, we know the length of this whole thing. So if we could find this distance right here, we could subtract it out and we would have the green. All right, so can we do that? Well, let's get this right triangle going over here. We know the distance from A to D. How do we know that? Well, it's the radius of a circle, and we know the radius is 14. We also know this length is 22, which means we know this one is 11 because it's half. This is a perpendicular bisector, so it's going to split that in half. So now we should be able to find this little piece right here. So we have a squared plus b squared equals c squared, or we don't know a squared, so 11 squared equals 14 squared. You want to pause the video and finish this, go ahead and use Pythagorean theorem here and go ahead and solve that. So solve for a squared and then take the square root so that we get a. All right, so now that you're back, you should have a squared equals 75, or a is about 8.66. All right. So from here, so that's this distance right here, 8.66. All right, so do we know this whole thing? Absolutely we do. So now we can take the radius and we can subtract off this part of the triangle and that will give us the green part. All right, so we have the radius minus 8.66, or AB minus AE gives me EB. AB, the whole thing, minus AE gives me EB. All right, so 14 minus 8.66, which is about 5.34, round to the nearest hundredth. All right. So we also know that if they tell us that a chord is a perpendicular bisector, then we know that it's the diameter of the circle, or it could also be the radius, but if it's a chord, it'd have to be the diameter. So if they tell us we have a perpendicular bisector of a chord, so let's say they say, hey, AB is a perpendicular bisector of CD, you know that AB is either the radius or the diameter. If they give you a picture like this, we know it's the radius because it's coming from the center. But if it's just information given, like on the EOI, they say AB is a perpendicular bisector of CD. You know that AB is the diameter or the radius. All right, let's get a couple more things and then we'll be finished. Okay, so if I have two chords, this is 10-5. If I have a couple of chords and they're the same distance from the center, then I know they're congruent to each other. And that's also an if and only if. So if I have two chords, and remember, when we draw distance from the center, it has to be a perpendicular bisector. I mean, excuse me, a line that's perpendicular, not a bisector, a line that's perpendicular. So these will move around, like depending on the slant of your chord, these will also be slanted to make sure that this segment is perpendicular to the chord. All right, so those guys are perpendicular. Two chords are congruent if and only if they are the same distance from the center. So that means if they mark these guys perpendicular, perpendicular, and they mark them congruent to each other, we know that this chord is congruent to this chord. We know that this whole thing is congruent to this whole thing, right? And we also know that if these two chords are congruent, then they have to be the same distance from the center. All right. Now moving to section 10.4. If I have a circle and its vertex, remember, central angles and their arcs that they intercept are congruent. So if my vertex is at the center, the angle measure is the same as the arc measure. If the vertex is on the circle, so this is an inscribed angle, the vertex is on the circle, then the angle measure is half of the intercepted arc, right? The angle measure is half of the intercepted arc. So if this is angle X and this is arc Y, X is going to be half of Y. So if I told you that this distance, or this distance of this arc was 130 degrees, then we know that X would be 130 divided by 2, or 65 degrees. Same thing would work. It would work similarly if I told you angle X. If I told you angle X was 40 degrees, then you would know that arc Y would be 40 times 2, or 80 degrees. Or if I told you X was 80 degrees, it'd be 80 times 2, or 160 for the arc. So if the angle is on the circle, the arc is going to be twice the angle, or the angle is going to be half of the arc. All right. If two arcs, hold on, I can't talk and draw circles at the same time. So if I have two chords and they intercept an arc, and then I have two other chords that intercept the same arc, so you can see this guy right here and this guy right here intercepting the same arc, these angles that are formed are congruent to each other. Those angles are congruent to each other. So if the intercepted arc is the same, if they intercept the same arc, angles are congruent. That means if I tell you this arc is 3x plus 2 and I tell you that this arc is 2x minus 11, we can set these guys equal to each other and solve. So subtracting 2x from both sides, we get x. And then subtracting 2 from both sides, we get negative 13. Let's make this believable. Ooh, if this is an EOI question, that's going to be a struggle, isn't it? Let's make this believable, get some positive numbers here. So let's make this negative, or excuse me, let's make this 4x. All right, so that would give me negative x when I subtract from both sides and negative 13, so x would be positive 13. When I plug this back in, I can find those angle measures. So 3 times 13 plus 2. So 39 plus 2 is 41. So this angle is 41 degrees. This angle should also be 41 degrees. If it's not, there's a problem. 4 times 13 is 52 minus 11 is 41 degrees. We know this arc is how much? If this angle whose vertex is sitting on the circle is 41 degrees, we know this is 2 times 41 or 82 degrees. All right, so that's the way we can figure out that arc. All right. We already talked about this when we reviewed for EOI, but I just want to remind you that if we have a arc, or if we have an angle and its endpoints are connecting the diameter of a circle, that makes this a right angle. Right? So vertex is here, connects the diameter, this is a right angle, which means automatically we should be thinking Pythagorean theorem. Okay? The other thing that we can think about is if they give us these angle measures, these two angles have to be complementary. They have to add to be 90 degrees. You can add all three together and set it equal to 180, but we know this is 90 degrees. So 8x minus 4 plus x plus 4 equals 90. So 8x plus x minus 4 plus 4 equals 90. Just rearranging a little bit, those add to be 0. 9x equals 90, x is 10. If we want those angle measures, we can definitely plug them back in. This would be 14 degrees. 10 plus 4, this would be 80 minus 4, which would be 76 degrees, and 76 plus 14 should give us 90, and it does. All right, know this is a long video, but well worth it. I have some problems for you to do as you come back to class. This is Coach Lowe, and I'm out.